So here we are on your Albert assignment that you're supposed to do. It was the one that was due Friday. Now, let's go and take a look at this one. There were quite a few questions in here, I'm aware. Let's go ahead and, it's going to take a while, but let's go through at least a good number of them and see if we can't explain why they are the way they are. Alright, so start off with the first one. I feel like all of you should have gotten this one. Really and truly, all of these things can hold integer objects except for the one which won't actually initialize. So if we use our elimination tool here, remember Albert has this elimination tool where you can cross out answers. We should really just be left with list C. For an explanation, it's this. List C equals new list will not compile. Remember, list is an interface. Therefore, it cannot be a new list. It has to be new array list. Granted, the other ones, they can hold integer elements. Because remember, it's integer, which is an object, and all of these other four are object lists. Alright, we'll do just one more of these easier ones. And let's take a look at this. Alright, so setting the following code segment with string J being, or string array of J being these 6 words. All we have to do is we have to figure out how exactly we're daisy chaining this along. So if we put it together, let's go to the most innermost set of parentheses, slash brackets, where we have J at 3 dot length. Well, J at 3 would be the word whale. Whale is 1, 2, 3, 4, 5 letters long. So that means that this term here, inside here, evaluates to 5. Thus it's J at 5 dot length, going one layer out. So J at 5 would be 0, 1, 2, 3, 4, 5. The A over here, the length of it is 1, and thus our last one then is going to be J at 1, which is the word B. They kind of break it down for you in the answers. That J at 3 is whale. We get the length. From there, we get a certain length of that one, so it's at 5. So then J at 5 dot length means A dot length, which is 1. So J at 1 is the word B. All right, let's jump ahead to counting integer grades. So these kinds of questions I know you probably don't enjoy very much, where we have multiple answers. And then our answers are things like 1 only, 2 only, 1 and 2 only, 2 and 3 only, 3 only. All these things where we could have multiple correct answers. Well, let's go ahead and explain it. Alright, so grades, and I'm going to zoom in just a little bit. Alright, grades is an actual test grade, as an array of actual test grades in numeric format. Grade counts is an array list of exactly 5 elements and is used to keep the track of the number of A's, B's, C's, D's, and F's, where it goes 0 through 4, 0 being A, 4 being F. Grades are on a 10-point scale, just like you're used to. So which of the following segments of code will go through the grades array in order to increment the counts and grade counts correctly? So we know that int grades is set up correctly, it's fine. Yes, I'm aware that there's no real initialization over here, but we're assuming it's already done. Same for this array list. We're assuming that we have 5 integers inside this array list, all of which are equal to 0. So if we're imagining going through it, we need to first just make sure that for any for loop, we are going through the grades array correctly, because we don't know how long grades actually is, so we need to make sure that we're going through it properly. So the first one is int I equals 0, I is less than grades.length, I++. Well, grades.length is accurate for an array. Remember, for array list, it should be a method called size, but for array, it is .length with no parentheses. The next one is also int I equals 0, I is less than grades.length, I++. So we know that one's also so far okay. And the last one is as well. Now, why did we just do that? Because because we want to start off by catching everything. We want to analyze these things carefully. If you were to just jump in trying to solve it, as in like going through the code and then seeing if it would work in your head, you're likely to miss really minor issues that would have stopped the code from compiling, which, yes, is something that can show up on these. Alright, so let's go ahead and go through it. First off, I have int c. Well, oddly enough, I don't really use int c all that much here, do I? Yeah, you don't really notice a c being used anywhere. So that's kind of fishy, but it on its own is not a problem. Let's see though. If grades at I is greater than or equal to 90, then we're going to set the very first element in grade counts to itself plus 1. So we're going to add 1 to it. Well, that seems fine, actually. If the first grade was an A, we would now have counted up by 1 for A. But it's the next one that makes it an issue. Let's say our first grade was 93. Well, in that case, we're going to set the first element of grade counts equal to 1, right? Because we found an A. But with how this code sets up, that is also technically a B, because grades at I then is also greater than or equal to 80. Thus it would add up B, then it would add up C, and D, and F. Well, actually not F, that's the only one that it wouldn't add up, because F has the less than or equal to. With all the others, however, a number like 93 is greater than or equal to all of these. The only thing this could accurately count up is a list of only F grades. Actually, of only D and F grades. That would be the only accurate list this could work for. So we know right now that solution 1 is not a good solution. It does not work. So I'm going to scroll down here, turn on our elimination tool, and I'm going to get rid of anything that has a 1 in it. Because I know it can't be 1. It must be either 2 or 3 or both of them. So let's take a look at 2. Alright. Now, pretending again that we have our number 93, and quick note, whenever you see this thing where it's like else, if, go ahead and just pretend they're on the same line. It's long story, mistake. It should be on the same line. Go ahead and assume that it is. Alright, so anyways, let's take our number 93 again. If grades I get at I. Alright, now let's pause right there. Really think about grades.get parentheses I. Let's scroll up just a moment. Grades bracket I bracket is greater than 90 is what we have in solution 1. Now solution 1 didn't work, but it didn't have any compilation issues. Like, it would compile fine, it was just a logical error. It would be a problem with how it actually gets the answer. Solution 2 doesn't use the brackets that solution 1 does. It does use the brackets, however, for grade counts, which is actually even worse. Keep in mind, your two things are an integer array and array list of integers. The integer array is grades. That means those brackets are what I should see for grades. And the .get and .set is what I should see for grade counts. So that means 2 actually won't compile. So right there on the bat, we don't need to go through any of the rest of them. Let's just go ahead and mark out the 2's. That leaves us with just 3, which, if we were to quickly look at again, we see int c being added up every time we have a unique grade, and then at the end of the loop, we go ahead and add in that number. Notice how C is not the number of grades because it's being reset on every iteration, but rather int C is the index for what grade count to increment. So yeah, that's what's nice about it. Nice 3 works fine, and you can see why the other 2 don't work. Alright, so this is one of those things where we need to talk. Counting the removes in an array list of strings requires us to remember that whenever we remove from the list, all of the indexes to the right are changing. So let's see what I mean by that. because this is one of those where you really need to keep it in mind. Otherwise, you will have a lot of trouble with it. So I'm going to grab this, and before we go into it, let's remember that we're dealing with a for loop that goes from 0 to the size of the animal's array list. Remember, it's an array list, so it's size. And then if the animal at that current element has the word bird in it at an index 0 or greater, remember that if it returns a -1, that's how we know it's not present in the array. That's just what index of returns. But if it is present in the array, it'll be somewhere from 0 to positive infinity. So if the word bird is in it, it's going to remove it. Now, if you were to just look at it and kind of eyeball it, you might say, okay, well that means bluebird, blackbird, hummingbird, and snowbird get removed. And then therefore only collie, lion, and cardinal would remain. But if we work it out, we see that's not how it works. So I go in here and I start off I equals 0, and well, that means we're looking at 0, and we determine there's no bird in it. So we go to the next word. Alright, so now I equals 1, we're looking at bluebird. Well, bluebird does have bird in it, so we remove it. Alright, now we go up to the next one, we go up to 2, and this is the point where you have to pay attention and notice that collie is at 0, bluebird is no longer present, blackbird is at 1, and we're looking at the word lion now, which doesn't have the word bird in it, so we move on. Notice that this lion is now 2, cardinal is 3, blackbird is now at 1. So we have skipped over the word blackbird. And then from there, it really is just marking these out. Goes up to 4, goes to 5, and now that it's less than the size, which is 1, 2, 3, 4, 5, or at least it's not less than the size anymore. So we're done. So we never actually get rid of that one. So we're left with 5 elements in the array, an array list. Right. And just make sure that that's what the question is asking. It is. Alright, cool. Alright, let's just grab a couple more of them. Yeah, okay, so let's get this one. Alright. So we have an array list of type integer, big I integer. So keep in mind that integer is what we call a wrapper class. There are a few of them that we have, and what the wrapper classes do is they allow us to use primitive types in an array list, because an array list needs an object, and lowercase little int would not count as one. Now, the wrapper class itself can actually be used like a normal integer, like a normal int. For instance, this one here works exactly as you'd expect it, even when you do things like sum plus equals n, when n is a big I integer and sum is a little I int. That's still just fine. Really and truly, the question here is, can integer and int mix? And the answer is yes, they can. These are all valid. Yeah, so you can do things like int equals integer, or plus equals in this case. Int can do a for each loop, or int in the nums array list. So even though nums is full of integers, we can cast it like this, auto cast really, it to little I int just fine. And then the last one, sum plus equals new integer of this, when you do new integer and then give it a numerical value, it's going to make a new integer with that value inside. So yeah, that's a quick one. Don't want to spend too much time on that one, but you can see how that works. Alright, so let's take a look at this one. Remove random element from an array list. Alright, so we start off with an array list of strings, and we're just going to assume that it's been properly filled with strings that we don't know. Alright, so int rand id equals cast integer math.random has list size. This returns, as you're hopefully aware, this returns a random number between 0 and the size of our list, whatever that size might be. Int I equals 0, and then for each string s in the list, if I is equal to rand index, then remove that element from the list and decrement I, otherwise plus I. Now this decrement I really want to focus on for a moment. Remember when we were doing the adding and removing? No, wait, not that one. This one. Remember we did this one and we talked about how it skipped over? Well, that was because we never decremented I after removing. This one right here does it properly and actually makes I go back by 1 before moving it forward by 1, so that way it doesn't skip any elements. Because when we remove, we need I to remain right where it is. Alright, so anyways, so yeah, we have that. If I is ever on that random index, we'll remove it, and then we'll keep going. But here's where we should talk about it. One thing is, it's going to be this, which we'll talk about in just a moment. But let's go ahead and knock out some of the others. Alright, so it removes a single randomly selected element from list. Now, why might that one not be true? Well, it's probably the one that seems the most true, since that does appear to be the intention of the program. However, also consider this. We are using what's called a for each loop, and a for each loop has this little rule on it that it will have a concurrent modification error. That if you are going through an array or array list using a for each loop, you cannot use the .remove command, because otherwise you will get this kind of error. It's more just that it won't allow it to. Now the part that might throw you off is that between A and B, it does come up a question of, well, hold on there, if I isn't changing, then isn't it always going to be equal to the random index after that point? But the more important thing to notice is just simply that for each loop. Let's say one other thing I want to jump into is this one. Yes, definitely. Okay. So this one. A two-dimensional array being printed out with for loops. Alright, the outside one is for int c, equals 0, using the columns. So it does the columns and then the rows. And let's just see how that works out. I'm going to use the snipping tool again. Alright, let's go through it. Alright, so we start off at c equals 0, r equals c, which is 0. So do notice that they were nice. They named this outer one after column and this inner one after row, which is actually what they're doing. So anyways, on that first part, we print out from row equals that through the length of the whole thing. 1, 2, 3, 4. So 0 through 3. So on this first go through, we're printing out the things in there at the first column. So we're printing out everything in the first column. 1, 3, 5, and 7. Right? So let's first just go back here. We're going to move anything that doesn't start with 1, 3, 5, 7. We'll leave that one for now, because if we do go out of bounds, we'll want to know. Alright, so let's keep going. Alright, so we finished that inner loop. Outer loop increments by 1. Let's take a look at what C1 would print out. Now R always starts off at what C is at, so that might be something that would throw you off. So just be careful with that one. So in this next row, or this next one, we're printing out everything from column 1, row 1 onwards. So we're looking at 4, 6, 8. And I think that's actually enough for us to know which one is the answer, because there's only one which does that right here. The only thing is the question of whether or not an out-of-bounds exception will be thrown. But here's the thing. We're going through the lengths. The lengths are never going to change. We're never trying to access C plus 1 or R plus 1. We're never trying to do C or R minus 1. And we're always staying well within those parameters. So it's not really possible that we're going to hit an array index out of bounds exception. So it's just this one, the one which actually goes down in number. There's a hint about this in the fact that R is always set equal to C, and C is a higher number each time. Prints out all 4 from the first column, just the last 3 from the second, last 2 from the third, last 1 from the fourth, and then nothing of any of the rest of them. Because R will never be less than the matrix length, because the length is 4. Meanwhile, the length of each row is so much longer. Alright, so here's another kind of tricky one, adding array costs using double data type. Alright, so we have this array of doubles called costs, and an array, a double for sum, which starts off at 0. We are navigating through our cost array with I equals 0, I is less than cost.length. That's all quite accurate. That's fine. It's .length because it's an array, so we're good on that room. Alright, and it looks like what we're doing here is for each element that's bigger than 25, we're going to add on to the sum cost set I minus cost set I, which at one hand might seem like it's saying 0. But this is actually not 0. When we do int cost at I minus cost at I, we have kind of an interesting thing going on. So let me go ahead and grab that. We have a PEMDAS kind of thing, where we cast it to an integer first, and then subtract it from what it was originally. So if we were going through this, we would start here at 20.25, and since it's not greater than 25, we go down here, sum plus equals the integer version of that, so that's a 20. Alright, and then on the next one, we would find a number where it is bigger than 25, and so then what we would have is sum plus equals 100, because that's the integer version, minus 100.75, meaning that what we're adding on is negative 0.75. So notice right there, I just converted that to an integer and then subtracted from itself. It's not subtract from itself and then convert to integer. It's this first. Almost as if we had like a multiplication going on. Alright, 10.5 just gets added in as a 10, because remember we are doing all these things to integer. Alright, and then lastly, 35.01 is going to be a negative 0.01. So if we put that all together, I could rearrange these and do the 30 and the 20, 10 and the 20 first to get 30, and then subtract the other stuff. But here, let's do it like this. We have 30 minus 0.76, which brings us down to 29.24, which if we look at our answer choices, it says which is the closest to the number, which is a little weird, but you know, is what it is. Closest to the number, 29.24 would definitely be this one down here. It does give you a little bit of wiggle room in case you get the wrong answer. Okay, there we go. Yeah, and that's just exactly what we were talking about there. Alright, and let's go ahead and do one of the difficult ones. Alright, so here's a difficult one. Assigning array elements from one array to another array. So we have int a, integer array a equals 10, 20, 30, 40, 50, and then b is equal to a. Alright, then as we're going through a itself, we are setting b equal to its a counterpart times 10. Now here's the thing. If I were to tell you right off the bat that a and b are like linked at this point, well, here, let's explain that. So this was based on a lesson we had about references. So inside the computer, you have what's called the random access memory, right? We talked about this once, at least a few times. Random access memory holds all the data that our program will be using during execution. For instance, this array called A, which is pointing to an array of elements like 10 and 20 and so on. When B is set equal to A, it's not B equals a new array. You know, it's not like, oh, okay, B is pointing to, you know, a new array of elements and all that. Far from it. It's the same array. And if I were to really like do it in a proper way, it'd be B points to A, which points to that. So so basically, B points to the same array. It has the same address as it. These are pointing to the exact same object. That is because arrays are objects. Any object would have this kind of thing with them. So when I'm in here and I do b at I equals a at I times 10, me changing b to 100 and 200 will also necessarily change a, because notice they're both pointing to the same array. So that means that they are both being set equal to that thing. So this actually is a pretty easy one as long as you know that rule. Now, one that is a bit more difficult to work through might be this one. array list returns 0. It's another one of those multi-solution ones, this time with 4 solutions. And it's asking you which one of these will return the number 0. So let's go ahead and dive into it. Alright, so we start off num equals 0. Our for loop is going from 0 through list.size. So that's all good. Size because it's an array list. Alright, so if list.getAtI is less than 0, then what we're doing is we're going to return, which remember return exits method C. We're going to return list.getAtI divided by the size of the list. Now, being as how these are integers, remember then that if you were to divide a smaller number by a larger number, that would actually return 0. So that's probably the thing that we're really looking for, is where we can get the arrangement to be something less than something divided by. Alright, so let's take the first one for instance. If we were to go through this and start it off, we would look at it and go, okay, well, 4, 6, -4, 9, and 22. We started off if list.getAtI, which we're on 4 the first time, is less than 0. It isn't. So we go on num plus equals that number. And we're going to actually add up the first 2 elements, because 6 would also be not less than 0. So up to 10 so far. Then we go to the next one, -4. So -4 is less than 0. Return -4 divided by the size of the array, which if we were to kind of work that out, that would be -4 divided by 1, 2, 3, 4, 5. In other words, it would be a 0 number when we are an integer. So it would appear that 1 is actually fine. Let's go and remove those other 2. So 1 actually would return 0. Alright, let's try the next one. Would number 2 return 0? It actually wouldn't. So let's talk about that. Int num equals 0. Okay. The size of the array list is 0. So we don't really even enter the for loop. We go down here, we return 0 divided by 0, which as you know is not allowed. So anything with 2 we're going to remove. And lastly, it looks like the 3 is the one that will return 0 as well. 4 does not return 0 because on its very first iteration, it's going to return -6 divided by 5, which is a -1 when we're casting to integer, which is not 0. But 3, for instance, will go ahead and add up all the numbers, get 4, and then return 4 divided by the size of 5. So that's why those 2 are the zeros. Alright, well, that's kind of a run through some of our Albert questions. Remember that now that the assignment's closed, you can see all the solution text descriptions of things, and you can go back and work through some of it. Okay, thank you very much. See you next time.